Well, good morning. We'll go ahead and get started. We have the three groups that are going to be reporting results of their discussions yesterday, and we'll just go through them in order. And Group A, Anessa was the leader on that group, so I'll turn it over to Anessa.
Good morning, colleagues. Yeah. Then you sit here, right? No, or you will help me how it will be.
Oh, either way, right here is good. Okay.
Oh, that will be better if I will see.
To see this?
Yes, over here better. Okay, that's great. Fine. So, do I have just to?
Just there.
That's here. Thank you. Sit here, please. So I have to present the results of our very hard work, which we performed yesterday with a group of very nice and experienced people from both sides mostly, but not only even from both sides, but more. And the topic of our work was what you see here, implementing space station research and sharing facilities. I would like to tell you in very short introduction that the work was very difficult for all of us, in spite of the fact that among the group people, we have people who are leaders in performing scientific research on station from both sides. Nevertheless, it was not simple to formulate those main obstacles for developing of a new stage of cooperation on the station, and to try to formulate the way of overcoming these difficulties. And at the beginning, we had very, very great discussion, even in understanding what is required for us. And I will tell about this at the end as the recommendation for future summits. But finally, when we understood and elaborate the main line of what we are doing, what we should do, I think it was extremely interesting, not only difficult, but extremely interesting discussion in which everybody participated. I don't know anyone who didn't brought something to our results of our work. But first of all, I would like to, there were people whom you all knows, but I would like to say special words about the person who took on himself and by himself the very difficult role of how to say to formalize sensible out of all the discussion, emotional discussion, the real, essence of what we are after and what we suggest. And this is Dan Burbank, and I'm very thankful to organizers of the summit who sent him to us to work with us, because He was just the main organizational person among us. And I would like also to give him stand to keep him word after I will present the main results. I have difficulties with languages, and it would be better if I will just present the formal statements which we have made, and then I would like to ask you to give attention, to pay attention, maybe 10 minutes more to what, or 10, 15 minutes more to what Dan will add to bring into this formal statement some additional explanations, okay? So, the challenges of work to create and to support cooperation. We selected in order of priorities. The very first is limited resources. Limited resources, the first of all, for crew time, because crew time, which is given for research on the station, on both sides, a little bit differently counted, but on both sides, it is 35 hours per week. And that is very small time if we will take in account that both sides have their own national programs. And we don't think that the program which we'll create now should ruin the programs which were already established from both sides. So actually, the program of cooperative research will require at least additional time. But even that time which we have now, it's very, very small time, not enough for sure. Now, funding, because we don't have funding for this cooperative study, for new cooperative studies, because funding are also, on both sides, are already distributed and planned for I know that on our side it is up to 17, and then now they take from us the planning up to 25. So the funding should be considered. Otherwise, it cannot be done. Anything can be done. Now, facilities. The new experiment, new research will require the widening the facilities, but maybe we have on the border quite wide facilities, but they don't belong to the whole team. They still nationalized, and I don't remember this word, but then they're segmented, and there are rules which don't allow us, as a matter of fact, to bring equipment from segment to segment, to use equipment for the people from the other segment, and so on and so on. That should be overcome, because otherwise we will have to duplicate, to bring new equipment, and so on. And also challenge is the finite operational lifetime on ISS, because the time which is given to experiments, every time it is just for some short time, and in this time very often is not enough to accomplish the research how it was planned. Now, the second very important challenge is that for today, each partner has its own research priorities. When we were discussing here the priorities, it seems that some of them are clear for both sides. They're unified, but that is not so. Inside the national program and from here to the program which they will insist on, these priorities are still different. Discussing yesterday, of course, we referred to successful experience which we had in the past. And almost all participants who had chance to compare the situation today with the situation previously, they kept comparing, and comparison was not in direction of today. Almost every second, third person was referring to Shuttle Mir, speaking about that integration which we had there. Not enough real cooperation between partners today. Not because it couldn't be done, but because of challenges, it was cut down. It was not wish of sides to cut it down, but it was cut down. And segmentation, which I started to talk about, it is brought harm to both sides, and not only in scientific program. This time the efficacy of research reduced because of segmentation, because of impossibility to share data, because of limiting sample size, and because of impossibility to integration the result. What barriers of cooperation? People were talking very much about this. That in a way it repeats what was said before, but each country has its own priorities, as I've already said. That is very great obstacle which should be overcome. Research team are still separated. Research team feel ownership of their own research. At the beginning, the people formulated this position. They said that it could be said that my research became more important than the research program on the station. In each country has a limited allocation of crew time. That's what I already said. Now, since 2009, and coincided with single flow to launch segmentation, has become formalized, with each partner being responsible for its own segment. That's what we know, how harmful actually it was and it is. Last year, Russian and American leadership determined that there was inefficiency and redundancy in research taking place across ISS for all countries. And currently, there is little or no sharing of crew time because low balance of contribution works, first of all. Data sharing is heavily constrained due to privacy, which now, previously Russian people were somehow not very much attentive to privacy. Now, they're already not only up to American, but even ahead of institutional requirements and so on. About segmentation, I already told. Then we were talking about what should be done to improve the cooperation. right now. And we know that we have hopes because there are very good examples of good, successful cooperation even today. Dr. Sowen talked about the joint experiment on biphosphonates, which the experiment is very successful. But when we asked him how much time and efforts it took to establish it, then we will find we don't have, now at the end of already this ISS flight, we don't have these efforts and even this time whatsoever. Now, excellent example. Everybody talked about this. Excellent example we have in organization of joint cooperative work on medical support of the participant of flights. MMOP gave us excellent, good example. And I think that, and the other people talked about this, that we have to take, not only we, but our leadership, who are organizing our work, they have chance and to take example from there. Now, Dr. Bogomolov helped a lot yesterday with work of the group because not all of us, I would say just on the opposite, all of us actually had no idea what formal rules for today we have, which we don't have even discussed. We can just mention them, that was decided, and this is bad. But what rules? What can be done? Because whatever is in rule, then the situation and the solution is different than when we talk about something what we depend on us. So I'm very grateful to Valeria, not only me, but the whole group, because it was very clear explanation of where we are, under what rules we are working, and what could be done and what could not be done. And we were happy to hear that this new multilateral human research panel for exploration was organized, because that was the suggestion which we discussed, that to make this program live, we need to create some sort of organization. And we were happy to know and to understand. Then this is already done, that such group is organized under leadership of John Charles. And this group is going and is given the task to integrate USOS and ROS life science research for the one-year mission. And then we discussed that this one-year mission should be used as a pathfinder for re-energizing cooperation across all missions, like the first step. And proportion of research resources which will be collected for performing this program should be allocated with the specific intent of establishing a broad multilateral research program. It would require very, very hard work of our senior leadership. It will be not easy because a lot of challenges which I just mentioned and listed, they should be overcome. And we were at the end of our work yesterday, we said, oh great, we finally organized everything and listed everything, great. But now, it was not, we understood that the real work is ahead. now, definitely, we need to overcome this segmentation and this separation of different experiments, different programs. And so we have to create the situation of sharing everything, sharing facilities on board and on the ground for pre-post-flight BDC. I will come back again later. And we thought that maybe wise people say so. It means that our leaders are already clever, because people said that it would be very nice to start with 1-2 experiments as a, Pathfinder's experiments, and maybe even to start with some new experiments rather than try to adapt and change the experiments which are already going. And Dr. Bogomolov said that actually they already done it, because they have selected 2 experiments. One experiment is with Chibis, with LVNP on board, and the other experiment with field tests, pre and post-flight, testing of cosmonaut and astronaut immediately, as possible, immediately after landing. And with satisfaction, the people heard that actually the organization of these experiments is going different from usual way. It's much speedy, much more fast, and much more up to the point, up to the goal. And what is extremely important, that all part of the support, of flight support, are working together. It's not so often. I mean, operational part, like starting from Mr. Safredini and down, and from medical support and so on, and scientific leaders. They work together, they help each other, and it helps already. And they, doing these 2 projects, they learn and they elaborate the ways of cooperation and collaboration. Now, there was said that it will be very important begin with defining realistic target date. We didn't talk about this. We ourselves didn't feel that we can do it, but we just make this recommendation to leadership that the target date should be defined, that people should know the timeline of events. Now, of course, we were not given tasks to define the topics of research. We were given tasks to define the recommendation for installation and implementation of research. But nevertheless, of course, these things are connected, and we talked about the topics of research, and we think that this research should emphasize life science research to enable exploration class mission, because this is the overall goal today. Then the special discussion was about funding, because we understand that without funding, nothing can be done. And at the same time, we thought about that somehow funding should reinforce the cooperative efforts. And therefore, it was formulated like that it would be nice to tie funding to success at building a cooperative program of research. Because people still will be doing their own research inside their own national program. But somehow we have to reinforce those ones who will work on cooperative program. And immediately the question about national laboratory research was brought up to the table. And all participants agreed that we cannot bring harm to this research. They are going and we have supported them, but somehow it should be found the way to bring them closer to cooperative program, at least in sharing data, because somehow to make it understandable that from this sharing data, everybody have profit. So, but that's also one of things which should be somehow worked out. How to implement for a given investigation, we discussed as well. So, how to make it, how to say, in fashion, to do cooperative research. So, we thought that cooperative experiment, when proposed, should specify number, country, and so on, and should be provided, should be funded. So the funding and resources, sharing of data, and everything should be specified and supported from leadership and from our management. And resources such as crew time need to be allocated according to jointly agreed priorities. So there should be, it is extremely important. Again, we came to the very beginning of my presentation to specify joint priorities, joint list of priorities. And we think that there will be big benefit, and we formulate like multilateral panel benefits. It is expeditious and efficient accomplishment of common research goals. It is could be applied to near-term goals. It may maximize what we were talking today during the panel, the crew sample size. It can optimize use of crew times, and it can expand analytical capabilities for data gathering and analysis using all partners' resources. Thank you very much. Now I would like Mr. Our main leader of yesterday work, Dan Burbank, to add non-formal words. Please.
Thank you.
His experience as a astronaut was as as important for us as Dr. Bogomolov experience in leadership. Thank you very much.
And I don't know if I can add very much to what Dr. Kozlovskaya has said, but I guess in general, I would say, from one crew's perspective, I look at this as, we have this magnificent International Space Station. It is so expansive. It is so capable. It's nearly 1 million pounds, and it is an expendable resource. We're losing time on it every day, every year, And we don't know if we'll have 7 more years. We don't know if we'll have 15 more years. I can tell you from our perspective, just being on board, there's far more capability to produce science than there is on the part of the facility than there is capability to produce science on the part of the crew. And so we're very short of crew time to be able to really capitalize and optimize the use of station. So I look at this just from the perspective of a crew as a problem that would be greatly improved, at least headed towards a solution by having the flexibility to have all the crew members on station participate in the science. There are times when things are less active in the US segment, times when things are less active in the Russian segment. We should be able to real-time shift crew time as needed so that none of the equipment is idle. And I would just say that segmentation, that term I always have a lot of difficulty with. I think segmentation is appropriate at the senior leadership levels when we talk about how we manage space agencies. But as soon as you get down to the level of the research, as soon as you get down to the level of the training and of the crew activities, I really wish we could do away with that concept entirely. We should be thinking about this as one station, one crew, one science program, and that's the way I think that you would make it better. To me, it's the easiest way to nearly double your sample size on all the life sciences experiments you do. And it's certainly one way to for the operator side of it to be able to more effectively, be conducting the experiments. And frankly, on the operations side, I worry sometimes if all of the US OS crew members are restricted to the US segment, our familiarity is always high with all the equipment there. If in general, the cosmonauts are restricting their activities to the Russian segment, their familiarity with that equipment stays high. But fires and ammonia leaks and orbital debris don't care about segmentation. They don't care about the level of proficiency of any given crew member. In the middle of the night, if something happens and Anatoly is in the crew quarters in the US segment, the more time he had been spending in the US segment, the better that would stand him in the way of responding to emergencies and whatnot. So from a crew integrity standpoint on the operations side, conducting all the science operations together has the added benefit in the unlikely, albeit potentially catastrophic event that you have to respond quickly to an emergency. And I guess, like I said, station is too precious a resource. We've all spent too much money, spent too much work to develop it, not to do the very best we could to optimize it as we go forward. I think what we're potentially proposing is a fairly significant overhaul of how we manage science on board the space station. And Nessa talked about all the very challenging barriers that we have to that. There's a lot of challenging barriers to putting 1 million pounds of hardware in space as well, and we jointly solve those. So I'd like to think that we would be able to solve these other issues as well. And I guess, in speaking a little bit out of my pay grade with respect to the science too, the parochial ideas that, this is my science, this is my data, goes very counter to the way I think about an international space station with that first word in its name, and that may be one of the hardest things. We talked about every country, every agency having its scientific priorities, but that goes all the way down to the research institutions and to the individual research teams themselves, and maybe that's just collectively a very difficult problem, maybe a social problem regarding how science is conducted. We are separated by vast different distances geographically, which make this more complicated, certainly. I know in preparing for the one-year science that Mikhail and Scott are going to be doing, the MERPI group that's going to work on that, to me, seems like the ideal opportunity to kick off a new effort that can be expanded to all the science on board. And so, to the degree that it's possible, it would be wonderful to think that that's just the first step, and eventually we apply that to 6 months missions and taxi flight short duration missions and commercial crew missions later, all in the idea of sharing data, sharing research, having COIs that are continents across the world, and doubling again, at least doubling the science throughput on station. That's it.
Thank you. Maybe somebody would like to say something?
Are there any comments from the audience? Yes, Bill.
I find it extremely disturbing that as the space station was started, it was an adamant. As space station was starting, it was an adamant position that the station, from the crew standpoint, was going to be operated as one contiguous spacecraft. And despite many arguments and discussions with both Houston and Soup, who each wanted to operate their part of the platform in the manner to which they had been previously accustomed, this was very strongly resisted and agreed to that we were not going to operate that way. I think it's very important now for this group to recognize to the space station program management that somehow we've gone backwards here. And this is not progress, and it's not the model for the future.
Just to add one thing, yeah, it's a great point, Shep, and it really falls upon the crew, each individual crew, to develop that sort of integrated concept and how they operate. And so I think in our particular crew, we had a very psychologically compatible crew, very different psychological types, different interests, and so forth. But we made it a priority for ourselves to have dinner whenever we could. Made it a priority, so we would spend a lot of time working out in the gym in ARED or in the cupola. We would do all the other kinds of things. We would fight to turn back the segmentation that was imposed upon us, partly by actually a relatively new thing, and that is the real-time streaming of video every day, all day. So from DPC to DPC, there's a camera that's looking down the stack in the lab. There's generally one on in the Columbus, one on in the GEM. So it's very apparent to everybody in all control centers and in all management offices which crew members are located where in the station. And I believe there was probably a hesitancy on the part of Anton, Anatoly, Oleg, for instance, to spend very much time in the U.S. segment because they had things they were doing over there, and there was probably some concerns about that. So it's an that I think is probably a healthy thing in general. It helps the ground, or it helps the world feel more connected to what we do on board, but it actually affects the behavior of the crew and negatively.
One short statement. I think that nobody can deny we're all friends. We want to be friends. We want to be together. The main idea, as far as I understand it from NASA, is to create conditions for cooperation. Speaking about the crews, the main thing is the reduction of the duration of the joint training stage. And it's not up to the crew. It's, again, up to, as Inessa saying, leadership, but I prefer to say leader. And that's another story. You can be very good guys, but if you do not know each other, it will be difficult to cooperate. If you are not trained to cooperate, you will not. That's the point.
So Shep, how much time did you spend with Sergey and Yuri over the 5 years you trained together?
4.5 years.
4.5 years. So the crew has pushed back on these very, very long training flows. Yeah.
I might add, something that was voiced at the last conference that I feel is also very important that we're all overlooking is that there are originally, in the early days of space station, quite a lot of argument as to who was in charge of what. And given that the station had only the air-to-ground communications and we had outages where we were passing over parts of the Earth where we didn't see ground stations for hours at a time, our position was if the crew had to act for the safety of the crew or to maintain something critical on the station, we were going to do it. And Mission Control and SOUP both fought this, and they said, no, you should wait till you see the ground and talk to SOUP or Houston and see that it's okay. I said, we're okay if we can wait, but if we can't wait, we're going to take the responsibility and do it. And this was Zavershonen, you know, this was absolutely forbidden,
Prohibited.
which is the wrong, this is the wrong philosophy. We have got to have understanding of the crew, that the crew's got the ability to make its own call when things are critical and take the consequences later, because this is the only way we're going to do expeditions in the future. We have to build this culture now. And everything I see is going the other way, and it's absolutely wrong.
Mm-hmm.
Any other comments?
So you've got to have something to say.
Bill, Annette and Dan, I think you've done a great job, I think, of presenting a real crucial issue that if we're going to be successful in the future, we have to do something about.
Yeah.
We're not going to get there if we continue the way we are.
Thank you very much. I think it was excellent topic for joint panel, and everybody was extremely enthusiastic yesterday, and all difficulty we considered, but of course during one meeting we cannot solve or even find the way how to escape, but at least that we understand the same way, you know. There was nobody who was against, nobody from leadership, because we had representative of leadership, from astronauts, because we had them, and from those who are doing experiments. All of us are unified, and I'm quite sure, I'm optimistic in my in myself, and I'm quite sure that if really the spirit will be like yours, we can overcome. It cannot be that 1, 2, 3 people, you know, who are doing different way, bring such a harm to join war. And thank you again for suggesting this topic. And George, and one thing which we discussed also, what I said that at the end I will tell for the future. For the future, it will be very nice to specify not only the topic, but maybe also some priority of questions which should be discussed, because we spent too much time yesterday. We are not sorry about it, because it gave us chance to understand who is speaking about what and so on. But nevertheless, we spent too much time to understand what we are after. Okay? That's for future. And thank you very much, everybody, and you especially. Mm-hmm.
Well, thank you both. Do you have anything written down on your recommendations and all?
All of this, their recommendation, we will give you this. Yes.
That document's available.
It is said it should be done this and this and this and this, but we are not those people who will follow this recommendation, you know.
No,
but recommendation
I think
Like a protocol?
yeah, your
protocol will be an independent.
your recommendations, I think, would help get that information to those people that can make the decisions.
Okay.
Yes, they have, it's on the computer there.
Then
Right.
he is excellent.
Well, thank you both. I think you have really addressed a critical issue that if we don't solve it, we're not going to get there. And
At least understand.
it's really the very heart and soul of research we do on station. And if we're going to make use of this great facility, we all have to address it and get it solved. Because as you say, Dan, the clock is counting, and we don't know how much time we have. And we need to make use of this facility that we finally have up there now, finally assembled, and we have the opportunity to produce, I think, great science if we can do it the right way. I'll call on Leroy, the leader of the second group.
Good morning, everyone. Thank you, George. So I was called upon to lead the second group, Group B, which was called Addressing Life Science Challenges and Long-Duration Human Exploration Missions. So we started out, first of all, interpreting human exploration missions as those missions beyond low Earth orbit, because they're going to be presenting new and different life science or exacerbated life science challenges. So we kind of tried to break it down into logical pieces. First thing we wanted to do was identify what we as a group thought were the most important issues, and that soon became a pretty big list, and I'll kind of read those to you. We came up with radiation, of course, is a very important topic. The VIP issue, with the intracranial pressure and vision changes, neurocognitive deficits, immunological effects, psychosocial, sleep, medical care, environmental support, and partial gravity. That was a new one that we haven't really done much work on, as well as the effects on a microbial and a cellular level. So then we added on a few more, readaptation, the issue if you're going to Mars and you've got to readapt from long-term 0G back to 1/3 G, and then on the return trip going back to 0G and coming back to 1G here on Earth after several months. Omics, of course, we heard a lot about omics during the last few days. Food and pharmacological agent stability, in the radiation environment and just general aging, and, automation of operations. So what we did was quickly realize that, okay, now we've got to issue some criteria to kind of down select what we think are the most important. And so the logical way to do that was to say, okay, what are showstoppers, what are not showstoppers? Or another way to look at that is, are these effects, what is going to be impacting the mission, impacting possibly mission success, or, acute problems, as opposed to maybe problems the crew might have years down the road after returning from the flight. And so we narrowed the list down to radiation, the VIP issue, neurocognitive deficits, because that's going to obviously impact operations, psychosocial, medical care, how you're going to provide medical care, and environmental support, making sure that the crew is in an environment both in the spacecraft and on the surface of the planet where you're in an environment that you can operate. So that was all very good. And then we started looking to, okay, so what should be the right approach to address these issues? And basically, we came up with three. Number one, of course, is understanding the cause. And in the case of VIP, that's very, very clear. We really don't have a good handle. We have some ideas on what might be causing the VIP issue, but we don't have a smoking gun, as you all know. So that would be a priority to figure out what's causing this issue. And also, once we do understand, then we can better go into the second part, which is prediction and protection. And then, of course, the third part of that is treatment. Okay, if it does occur, how do we treat the issue? So after we discussed this for a while, one of our colleagues very wisely pointed out that we were reinventing the HRP roadmap. And I think Bill took great comfort in the fact that the group pretty much affirmed or agreed with the HRP roadmap. And so we started kind of thinking along different lines. Now, before I get into those, so we actually discussed several things, and not only the topics I came up with there, but other ways of what would be relevant to Beyond LEO missions. And so we ended up finding basically three, I'll call them affirmations. They're not really findings. They're affirmations the group is endorsing. And so number one was we're affirming the HRP roadmap, and so that gave Bill a lot of comfort, as I said. Number two, and we're already doing this too, so this is another affirmation, is the interaction of these different factors on each other. An example, of course, would be radiation exacerbates a lot of different things, the cardiovascular, neurocognitive, et cetera. And Bill affirmed that, of course, HRP and NSBRI are working a lot on the more interactive type of research. So that was the second point of affirmation. The third one had to do with the duration that you're out there. And so we were, as a group, felt that we should endorse or affirm the efforts to develop propulsion technology and shielding technologies. And micrometeoroid debris shielding technology, such that we can get a vehicle to travel faster to cut the transit time to a place like Mars and back and minimize exposure to radiation outside of the magnetosphere. Then we started talking a little bit about other issues, and we decided really where we could contribute once we had affirmed everything that was already being done, was that we ought to think about, well, I'll start with just a story. You know, when I was back working a few years ago on the Augustine Committee, I was reviewing a requirements document for the Orion spacecraft, and you know, I was really surprised talking to some of the Lockheed guys that the aeroshell, the actual aeroshell of the Orion only weighs less than 1 metric ton. Okay, but of course we end up with a vehicle that's fighting 25 or more metric ton weight, you know, weight gain. And so, you know, what goes into that? Of course, it's the requirements that's going to drive the mass of the vehicle. And so I found one requirement that said the Orion was going to be required to be able to support a crew of 6 in spacesuits for 6 days. You know, to keep the crew alive and relatively healthy for 6 days in their suits in the Orion. And that, of course, protects for the case where you've just done the translunar injection and suddenly you develop a leak or a problem with your cabin, and so everybody has to get in their suits, and then they have to go do a free return, you know, like Apollo 13 around the moon and stay alive for 6 days. Well, of course, we didn't have that in Apollo, and this kind of gets into some of the points we were just discussing about, you know, the culture has changed. We're going out exploring, but we're expecting it to be, you know, not as safe as an airline, but you know what I mean. Our culture is kind of going more towards, you know, making things, safety is number one. And of course, you do want to be safe, but if you're going to explore, you do have to accept some risk. And so we decided that one of the things that we could put forward as a recommendation, or, you know, that we had a long discussion about, was that we need to figure out what the right numbers are. For example, radiation. You know, the radiation limits that we have now for low Earth orbit are based on OSHA standards for radiation workers that don't really apply, but that's kind of where you start. But we've, you know, and they're not hard and fast rules for NASA, but we pretty much adhere to them. And so we don't let people fly missions much longer than, you know, maybe a year, a little over a year in cumulative time. We basically tell them they're done flying, just to kind of err on the conservative side. And maybe that's okay for nominal ops aboard something like an ISS. But if you're going up to Mars, obviously you don't want to have that same requirement, your, you know, guideline or requirement, drive your design. It drove the Orion, you know, has driven Orion pretty much to its knees, where all the radiation protection has come out in order to bring the weight down to something that, you know, a vehicle that we're trying to design can lift it. And so we wanted to do, we were recommending, number one recommendation was to fund research or do research to figure out what those numbers ought to be. You know, get some more, as much as we can, get some basis to putting out some realistic numbers, something that, you know, of an expedition, not an expedition, of an exploration class mission, you know, we've got to be accepting a higher number as a risk number. You know, I've seen reports in the past that say during the Apollo program, you know, basically it was let's get it done. You know, we have a deadline, let's get it done, and we'll make it as safe as reasonably possible. And then, you know, years later, the analyses were done, and the estimates were that the mission loss of mission numbers were probably about 10%. You know, so maybe that's a good place to start for Mars. For the first Mars missions, would that be a reasonable number? But we want to try to put a little bit of basis behind that. So that was the number one recommendation. The second thing that we talked about were along the way, you know, as we develop these missions to build up to the capability of sending a crew to Mars, we ought to be thinking ahead and collecting as much and storing as much sample as possible, because a lot of technology, if you take a look backwards, you know, with everything that's happening nowadays in ease of DNA analysis and omics, if we had samples from way back then, we would learn a heck of a lot now. And so we wanted to be forward-looking and saying, okay, all current and future investigations, let's take and collect and store as much sample as we can, because we don't know what analytical techniques are going to be coming down the road. So that was recommendation number two. The third one focused more on the medical care, and it was, okay, we're doing things on board now. We have telemedicine. The ultrasound has been very, very successful. We're doing them operationally now with remote guidance for these optical nerve sheath diameter measurements they're done regularly on each crew member. And, but of course, as we start talking about going to Mars, the time delay is going to make that, you know, pretty unwieldy as we get farther away. And so we talked, you know, and I know there's some work being done on this already, but we wanted to emphasize the importance of thinking that way in research that we're doing, in promoting the transition from, okay, when you first get into space, you can do the telemedicine for a while, but as you get farther and farther away, you've got to transition to more autonomous operations. So that was pretty much what we came up with, the 3 affirmations, and I'll kind of repeat them. Number 1 is that the HRP, we think the roadmap is going in the right direction. Number 2, the emphasis on interactive research is also the right direction, because as I said, more and more we're recognizing the interactive nature of all these things. Third one was propulsion. Let's do what we can to cut the transit time to limit the exposure out in deep space. 3 recommendations were: 1, focus on research that will help us set reasonable standards and requirements such that we don't design ourselves out of the mission. And number 2, collect as many biosamples and store them as possible for future use, so we can, once we make more advances in analytical techniques, we can take a look back and learn a lot from what we've already done. And number 3, emphasize an area to make the transition from telemedicine to more autonomous operations. Okay, thank you.
Are there any questions for Leroy? None at all?
Nailed it.
Well, thank you, Leroy.
Thank you.
The third group, Carl, go ahead.
How do I get the thing on the screen? Oh, there we go. Well, good morning. As usual, in the Education Working Group, we had stimulating discussions with strong opinions expressed, and eventually we reached convergence. And I think that's a sign of good meetings. There were some 16 people who participated in the group this time, and they came from mainly the USA, but 1 or 2 other countries were represented, and they came from government, industry, universities, and non-government organizations. Last year we spent a lot of our time really focusing on the outreach aspect. This time we spent more time dealing with the education system. And we felt that there were several threats to the continuation of robust space programs, threats that we needed to be addressing. The first was dealing with the general category of human resource development. We were not persuaded that we were meeting the human resource requirements, either in terms of the number of people who would be needed or the skill sets that fresh graduates brought to the workplace. There was a huge amount of on-the-job training that was required to make them useful. And as well as that, the whole question of the knowledge base that has been developed over the years in the space sector was not being captured, it was not being shared, the know-how. And this is going to be critically important as we move forward into future programs. And then finally, regarding the resource development, we thought that the sector as a whole was not paying adequate attention to continuing education, to keep the workforce up to date with what is really a very fast-moving environment in terms of how we gain knowledge, how we transmit it, how we share it, and how we work together. there were concerns being expressed about funding. And one of the threats that has hit a number of agencies, and certainly the Canadian Space Agency is one of them, and it looks as if the latest budget proposals will affect NASA as well, and that is that the funding that those agencies had available to them to directly sponsor research or education programs was being moved out of the agency's authority into central agencies, whether they be granting bodies or whether they be just education bodies. There is little question that when this happens, the influence of agencies, both in terms of their capacity to stimulate research and in terms of their capacity to influence education, is diminished. The dollar is important. We also noted that many universities were already suffering from inadequate funding to support graduate level space research. And this is something that needs addressing. The final topic finding under education was that the research databases were not being shared broadly enough to tap into the knowledge base of a much larger research community. And so what are the recommendations that would come out of these three areas? In the human resource and capacities, we think that one of the steps that is an essential precursor is that we need to identify what the realistic human resource requirements and skill sets are for robust national and international space programs. And this shouldn't just be done by agencies. It should be done with the industry, the education sector, and government. And this should be done on the basis of what are the realistic programs that are going to come down the pike over the next 10, 15 years, and make sure that we have a match between what we currently have, what we expect our workforces to be, and what we shall need, and work together to make sure that we can make the progress that is necessary. We need to pursue knowledge-based capture on best practices in the space sector as the workforce is renewed. And we need to actively pursue continuing education in the workforce to keep it current. So those are the three, if you like, sub-recommendations dealing with human resources and their capacities. On the funding issue, we need to see how space agencies can continue to support interest and development of space activity in research institutes and academia in the event that space agency funding for education and research continue to be transferred to agencies responsible for education and granting agencies. We've got to find a mechanism for ensuring that the type of level of direct support that was given can still be given, even if we have to work much harder with the other agencies. And it will not be easy. I think this is a very challenging task indeed. And then we need to address how university funding can be augmented to better support graduate level space research and space workforce development. I would make a comment that I think we're moving away from the easy ways of doing this, and we obviously have to do much more cooperation with other agencies to make this sort of thing happen. And then on expanding the research network, we need to share the research databases more broadly to tap into the knowledge base of a much larger research community using modern communications and analysis tools. Now, I know there are restrictions as to how some data, particularly in the medical field, is shared, but we heard several times during this summit of how there are resources available that could add so much to what we do with the data, and we need to find a way of dealing with that. Well, that is really the end of our education recommendations. On the public awareness and outreach findings, we had a quick look at what we recommended to this body a year ago, and found that most of the findings and recommendations were still valid. And it does raise the question of what do we do with these recommendations that we bring up at meetings of this nature? They're collective and very often very sensible recommendations, but who is able to do something with them? The other comment we wanted to make is that when properly exposed, space activity continues to be inspirational for the public. We keep on seeing signs of this, that when the public is reached and well reached, they like space, they're enthused about it. And that's an important aspect. So how do we deal with this? Well, the first thing we think needs to be done, and it needs to be done on a short-term basis, is that we need to attract and retain experts and respond to the demonstrated importance of social media for increasing public awareness and expanding outreach. We know the tool is effective. We need to make sure that the people who can use those tools effectively are part of our workforce who can help us do that. We recommend using TED Talks and similar outlets that have wide electronic distributions and followings. This is really a huge number of people, including policymakers, who tap into vehicles like this to expand their own knowledge, and the space community needs to use it better. And then one specific recommendation that came about, which we felt maybe could be done through a group emanating from this collection of people, is that we involve school children in an around the world SEEDS-like program. The SEEDS program has been used to really engage children on a national basis and has been extraordinarily effective. Why don't we try and do this on an international basis at some time, so that we have children all over the world engaged and involved and sharing information? And maybe it means we have to have different seeds because they won't grow all over the world at the same time. But something of this nature, which collectively engages children, is something that could be stimulated out of a group of people like this. I'd like to thank all the people who contributed to these ideas, to these recommendations, and I hope they're useful to the group as a whole. Thank you, George.
Do you have any questions?
Yeah, Jeff? Oh.
Thank you. The last point regarding the seeds, there is a very good program designed by NASA and joined by ESA, and is even been spread in Russia. It's called Mission X, Train Like an Astronaut. It happens every year now for several years, starting in February, and it's designed for schools for children to have a healthier lifestyle. So they're taught how to eat properly, they understand their body, they understand their perception and cognitive abilities. And it's a lot of astronauts actually do visit the schools during that time, and it's a very effective program. So if we could engage more people, as well as medical professionals, as well as astronauts, in this program during that period of time to visit more schools, because that's how kids get more excited, in addition to being a program, This program allows children to interact via the internet, so they all link up together. They understand the international component of it. They speak different languages, and they exchange photographs and their achievements, and every activity they do adds up to one step from the Earth to the Moon. So the kids could see throughout that month, so 6 weeks, on how fast they jointly together around the world can take steps towards the Moon. And this year, I think they've exceeded the Moon in their steps. So it's quite
That's
fantastic.
a great program, and maybe we can tap into it with some other vehicles for
Absolutely,
joining
and they'd be
together.
More than happy to.
If we could get some information, more information on that.
Sure.
We could
I will.
put it out to people so they become more aware of it,
Mhm.
what they participate.
It's cool.
I'll make a comment on that, George. Oh, he's here, yeah. Chuck Lloyd. I sincerely appreciate the acknowledgement of what's going on with Mission X. It is it's now in 22 countries, and we salute very much to all of the countries and the space agencies that have participated. This is really thematically based on the World Health Organization. There are a multitude of issues that, if you want to reach internationally, you should look to the WHO. Obesity and issues with physical activity is a global issue. It's not just anyone's personal issue. And that makes a powerful statement. Space programs is a wonderful way, especially with children, to make that extension. George, directly to the comment on awareness, I'll be more than happy to feed into the group the connection to the website, number one. Number two, we already have electronic as well as paper flyers that talk about how to join and to provide the information about how you connect either through us at NASA, ESA, ASI, UK Space Agency. It's really kind of cool. We've had a nice connection. By the way, we're in 15 languages. And what almost looks like a House of Babel, when you look at the blog, it's a very powerful piece. You may not be able to read the words, but the images, the video are very powerful in sending those messages. We also do country reports followed by an annual report summary and then up to an executive summary. That'll be coming out later this year for Mission X13, and we'll hopefully be ready to go on MX14. So I appreciate the compliment and most definitely here. One of the struggles I'd like to share, what is just now beginning that we see here in the United States with a drop-off in funding inside of NASA for education, as well as we see in Canada, as well as we see in ESA and everywhere else, it strikes me, what are we doing wrong? We think we're doing great. We think we're the best. But obviously, our political structures don't agree. The COSTEM business in the United States essentially concluded that NASA really doesn't need to be doing those things. They need to be staying more focused on their main programs and let education be done by someone else. And I got to be careful with that because, you know, MURAP and other EPSCoR and other programs remain inside the agency. But clearly the trend line, mathematically, the trend line on finances is going down. It's not even flat. This is a serious problem. And you're taking people out with statements such as, if you're doing education inside the agency that is not directed out of a specific organization, you are to cease. That is bad. But unfortunately, it is happening. What did we do wrong? It strikes me that we are not clearly articulating what impact we are having. Now, this is tough. You can show inspiration. You can show excitement. I mean, Mission X, SEEDS, or other programs show that. But obviously, it's not enough to get you funding. So it begins to look at some of these other metrics of measure that you have made an impact. What I seek from the very smart educational groups, and I don't believe mine is got all that smarts, but I do believe Bill Thompson and others in NSBRI and other agencies do, is what kind of measures can we gang together on and use to show those metrics year after year after year. Mission X has done it kind of simple. You heard me say, it's almost senatorial. 22 countries, 15 languages, blog, blah, 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 blah. It does help, but I think we need more. And I think you need to show that you've made an impact. That's.
Thank you.
I would have to say that I'm very pleased that Chris Hatfield was not guided by that, the leadership that has given us that kind of actions. So fortunately, I think he has really had an impact, and an impact that I think has increased awareness of space and the benefits of space immensely around the world. So
we got to keep doing it. We got to
That's
get
right.
right behind it.
That's right. I think we need to continue to do that kind of thing. Any other comments? Yes.
Yeah, I just would like to report also an activity which is the Humans in Space Youth Art Contest. There's an activity which was started by NASA and USRA. It was done, the prize awards were given during the recent Humans in Space conference in Houston. Now we are repeating this, or we have repeated this for a second time now, and the prize will be given at the Humans in Space conference in Cologne this year. So it's organized by USRA, supported by NASA and by my institute. We had a huge enthusiasm. I think it was over 2,000 submissions from, I think, over 50 countries. And the real moving things are music compositions. Those young people are so active and so creative and so enthusiastic. So this, I think, is a positive example, and I just hope that this will go on in the future, and that like NASA will also support this in the future, because I think this is real great and shows the enthusiasm of the young people around the world.
That sounds like a great program.
One in the back, and then Jeff.
Deborah Mansfield here from Houston. Here in Houston, we have a program that is supported by the Methodist Hospital Research Institute, University of Houston, as well as NASA Johnson Space Center, that's called Pumps and Pipes. And one of the things I think we're overlooking here is maybe the insulation of just staying with space, but not looking at other industries that have maybe had similar challenges, that already have data sets, but also have individuals that have already solved some of these problems. So you have these individuals that are corporate. These are business partners, maybe in oil and gas and other areas, that are working with universities, but also could be a resource for the space organizations. Another component here is that the big elephant in the room that I think we haven't addressed is that the corporate partner. You know, space is being commercialized. And so you have individuals that do have money. We're approaching this concern for funding, but I'm from life sciences. So we have had in life sciences with universities something called sponsored research agreements, where large corporations have provided research funding to support research that may be able to spin out technology that could benefit man. This could be also another model that the space organizations could be using, where you have large corporate partners that might like to fund the universities, no matter where they are in the world, because sponsored research agreements are ubiquitous to country. So this could be a model for this organization, not to look at your governments, not to look at the federal government for funding, but to look for a corporate partner that also would like their employees to benefit by health solutions or by technical solutions or the ability to commercialize. So I think I haven't heard much, and I apologize, I wasn't here yesterday, so if this was broached, but your corporate partner, your industry partner, your commercialization partner could be part of your equation Pharma is coming back into the universities, allowing people to be instructors there to help with the models that they have used in the privacy of that organization for R&D. You know, it's not just the university who's doing research, it's also your industries. So I would say that's also a benefit that hasn't, I think, been addressed by this organization, and that could be a resource because they do have funding. You know, it's just not SBI or STTRs from our feds, but it's also corporate, and they're not just the devil in sheep's clothing. Thank you.
That's a very good point. There's a program that Francesco Fusco is going to tell us about that they've started with all the high schools that I think is going to be a very good program to reach out to young people.
Yeah, one of the things we're trying to do, we're trying to create a program which will be a competition internationally to actually send an experiment up to the space station. We worked an agreement with NanoRacks. We're doing a pilot program right now. We currently have outreach to local school just to see how the program will work. The response is unbelievable from the students, and we are reaching not just high school, but even, you know, all kinds of even younger kids. They're still enthusiastic. So we have different. We're trying in different school. Right now we're doing towards low income. So we give the possibility to the kids that they are not really. They don't have that possibility to try to show them that there's other things that they can do, and response is good. The idea is next year we're going to fly 4 experiments now on Cygnus 1, scheduled now in September, I think. But next year the point is try to expand this internationally to schools. So we're working on protocols how to deal with this. But basically all the school will submit their idea for experiment. We will have a commission that will basically choose the experiments, the best experiments to fly. But all the school involved in the program will be aware of the experiments they're flying, and they will all receive the data. So when you submit the experiment, you will have to sign an agreement that you will share your data and your experiment information. So to keep activating all the school at the same time, even if their experiment is not flying. So that, you know, we're still work in progress, but we are, as I said, we already started with the pilot program. They already delivered the experiment. We chose some 4 experiments, and they're going to fly in September. So things are moving, and hopefully we'll reach out for collaboration.
I think the schools that you've already gotten involved with has had a tremendous impact on the young people.
Yes, they are.
Any other comments? Well, I think your point is well taken, Carl, about where do these recommendations go. I think we had the administrator of NASA with us up through Friday, and we're going to certainly make him aware of our recommendations. But also, I think all of us need to look at the best way to ensure that some of these recommendations really get acted upon. And I would solicit all your assistance in making that happen. And Bobby and I are going to certainly look at ways that we can pursue that. Any other questions at all on any of the groups? Well, we're very fortunate to have available this morning a video that Dr. Ushakov has brought that is going to be on the 500-day study. We didn't get into a lot of discussion of the 500-day study in detail, but I think this video will be an excellent way of getting a good appreciation for the study. So if we could play the video now.
Проверка связи. Loud clear. Громко и отчетливо. Пожалуйста, включите вентиляцию для скафандра 6.
Подмосковный город Королёв. Центр управления полетами. 13 часов 30 минут. В историческое для человечества мгновение потерян контроль над марсианским кораблем.
We lost control over Martian vehicle. Signal travels about 40 minutes, which is too long in a catastrophic or critical situation.
Расстояние 55
The
миллионов
distance
километров.
is
Первый
55
десант
million
землян, находящийся на
kilometers.
Марсе уже вторые сутки, переходит в отсек хранения скафандров.
A
До
crew
выхода
member
на
goes
поверхность чужой
to
планеты
the module
несколько
where
секунд.
the spacesuits are stored. We have several seconds before they go on Mars. We're ready for exit.
Мы готовы открыть люк.
We're ready to open the hatch. Volunteers of the Red Planet. Day 1 of the mission.
Межпланетный корабль вышел на орбиту Земли.
Interplanetary vehicle
Впереди 8
entered
месяцев полета к главной цели экспедиции –
beyond
планете Марс.
the Earth's lower orbit. Ahead is their
Экипаж
final
исторической миссии 6 человек.
destination.
Российский медик Александр Смолиевский,
The crew consists of
член
6
китайского
people.
отряда космонавтов Ван
Doctor
Юэ,
from the Russian crew, Chinese crew member Van
инженер из
Yue,
Италии Диего
Italian
Урбино,
engineer Diego
Суфров
Urbina,
Камолов,
Dr. Sufrov Kamolov,
французский инженер Ромен
French
Шар,
engineer Romain Charles,
командир корабля
the
россиянин
commander,
Алексей Ситев.
Russian crew member Alexei Sitov.
Мы все находимся на космическом корабле.
All of us
Я
located on a
счастлив.
space
Всем
vehicle. I'm
привет
very
и до
happy.
встречи.
Hi everyone, see you later.
Bye. Bye-bye. Ну, bye-bye. До встречи.
Nah, bye bye, see you later.
Впереди сотни научных экспериментов.
Ahead of them are
Ежедневная
hundreds of
проверка здоровья,
scientific
занятия на
tests,
спортивных тренажерах,
health check,
несколько раз в сутки связь с Землей. А для
exercises,
души переписка с родными, от которых марсианский
communication with
корабль
the ground,
уносит тебя со второй космической скоростью.
and communication
Больше 11 километров в
with your
секунду.
families that you're going further and further away from.
Новостей у нас мало. Со здоровьем у
Have a
меня
whole
все
lot of
хорошо.
news.
Летим на Марс.
Feeling good.
Колебания
We're
температуры
going
минимальные.
to
Воздух
Mars.
очищенный, как в метро.
The air is very clear here, just like in the metro station. We got married a month before the mission, and we communicated through email that Alexei would send to MCC, and then the psychologist would forward it to me, and I would respond through her back to Alexei. He told me that he lost track of what seasons would be on Earth. He can't have a good sense of whether it's
Марсонавты
summer
понимали, как бы ни
or
было
fall.
тяжело, родным на Земле еще труднее.
Astronauts knew that even though they're enduring hardships, it's even harder for those that they left
Суфров
behind.
Камолов, врач экипажа,
Суфров
в своих
Камолов,
письмах старался подчеркнуть,
Crew
что ничего
surgeon tried to
необычного в этом
emphasize in
полете
his
не
emails
происходит.
that there is nothing unusual in the course of this flight. Short-tempered usually, but
49 суток
or
корабль
I was
по
asking him if there's
спирали
anybody
отдаляется от Земли.
short-tempered in
На
the crew, and he
50-й
said
день
no.
точка невозврата пройдена. Земная гравитация уже совсем не
50,
влияет на корабль. Если
when
марсианская миссия завершится
The
успешно,
gravity pull of
встреча с
Earth
родными
has no
только через
impact on the
1,5 года.
vehicle. If the crew is successful, they will see their families in a year and a half. After day 50, the trajectory of landing is completely different. We would have to go around the sun and back to the Earth.
На 50-й день корабль окончательно
Day
уходит от Земли
50, the
и берет
vehicle
курс на планету Марс.
is aiming
Отступать уже
directly
некуда,
to
да и
Mars.
некогда.
There is no return.
Такое ощущение, что прошло уже много времени.
I
Что
feel
все то,
like
что я
it has
знал
been a lot
раньше, где
of
жил,
time
это
already.
было очень
And
давно.
everything that I knew before, where I lived, that all was very long time ago. When you fly towards Mars, the first month, it is very important that the crew will get adjusted, the crew members will get adjusted to each other, that will understand well that you have people whom you have to respect.
The doctor said jam, honey, butter, or kasha. What is this? It's cake? Ah, okay. Cake too? No.
Trying
У
to
нас
learn
тут свой
Russian
Ваня
words.
есть, из Китая. Правда, он у нас
We
немного
have
опасный.
a Chinese
Вот он как-то
guy
во
here.
время дежурства и выключил подачу кислорода.
He
Хорошо, я
turned
заметил.
off
Я объяснил
oxygen
ему, когда и что надо
accidentally
выключить.
here. It was
Сегодня
an
опять
accident,
дежурит,
of course.
пока без происшествий.
He is on shift today. So far, nothing happened. I explained to him what he did wrong.
Первое
I think he
ЧП свалилось на
understands.
экипаж через
Well,
сутки после
the
письма
first
Алексея Сетева жене Екатерине.
issue
На корабле
occurred
отключилось электропитание бытового модуля.
a day
Это
after
нештатная ситуация
Setov wrote to
стала
his
жестким
wife
испытанием
that
для
was
всего
no
экипажа.
phenomenal. Heating was shut off.
13:23
Oh, electricity was shut off.
Сегодня в
This is,
13:23 у нас отключилось
The 1st
электропитание.
of December at 13:33, we
Мы
got
работали с аварийным светом,
power
без системы
outage.
вентиляции. Нам
We
удалось продержаться
had no
ночь, хотя уровень
AC,
углекислого газа серьезно
and
повысился. И даже
CO2
показалось, что мы
increased
задыхаемся.
tremendously. We felt that we didn't have much air.
Электричество появилось через 18 часов. Так же
Electricity
внезапно,
came
как и
back
пропало.
18 hours
Последствия
later,
короткого замыкания
suddenly.
ликвидировал главный
That was
компьютер
just a
корабля,
shortage.
перезапустив
The
процессор,
central
отвечающий
computer
за
got
бытовой модуль.
restarted, and after recycling, the power came back on.
Итак, сейчас 9 часов утра.
Right now
Система
it is 9
жизнеобеспечения
a.m.
снова
Life support
функционирует.
system
Слышите звук
is
работающей
working again.
вентиляции?
Can you hear
Снова есть
AC
кислород.
working? We
Есть
have
чем дышать.
oxygen again. We
Спасибо.
have air. Thank you.
Мы получили полновесный,
We
хороший коллектив,
got
который
a good
сообща
crew.
решает те проблемы, которые перед ним
They
возникают.
were able to resolve issues together, and they did
Начиналась
it
вся эта
well.
история на Земле за
All of that
2,5
happened
года до
on
марсианской
the,
миссии.
started on the ground, 2.5 years
Кандидатов в
prior to
космический
Martian
отряд отбирали
mission.
в Московском институте
The
медико-биологических
selection was
проблем.
done at Moscow Institute
одна
of
из
Medical
самых
Biological Problems.
Заявок на участие в
That
экспедиции
was a
более
strict
6
committee.
тысяч со всего света.
Over
Международный экипаж
6,000
6
people
человек, все
applied,
мужчины.
and only 6
На
men
первом
were
этапе
supposed to be
комиссия не возражала
selected.
против женщин.
Initially,
Тем более, что
they
заявок
didn't
от
mind
представительниц
a woman
прекрасного
would
пола
be
было не
on
меньше, чем от
the
мужчин.
crew.
И все же
A lot
комиссия
of them
решила,
applied.
женщин в первом полете не
However,
будет.
they decided that there will be no women in the first flight. It's not quite clear, I believe, how to psychologically select a woman here, because a woman is a little bit unpredictable. Her mood may change. You cannot really calculate and predict exactly as easy as men what she's going to do. Besides
обязательно
skills,
уравновешенный характер.
people have to be psychologically balanced,
взаимовыручка, по сути, половина успеха. В этом будущие марсонавты
half of the
убедились, когда
success.
примеряли скафандры для своей
They
экспедиции.
actually got approved when they were fit checking the suits.
Выходишь из поддерживающей тележки, в которой находится скафандр, это то, что
When
если
you
ты сейчас
get out on
упадешь,
your
тем
own,
более на спину,
in your
то ты уже не
spacesuit, if
перевернешься
you
и не встанешь
fall
без
down,
посторонней
especially on
помощи.
your back, you
Ранец,
will need
который находится на
somebody's
спине, он достаточно
assistance
тяжелый,
to get up. You will not be able to do it on your own because the backpack is quite heavy. You will feel like a turtle on your back if you fall
До
down
сих пор
on
в
your back
российской
in your
космонавтике
suit.
использовали два типа скафандров. Одни для полетов на
Previously,
МКС,
two
другие
suits
для
were
работы в
by
открытом
Russian
космосе.
cosmonauts for EVA and for
Для Марса
IVA.
такие скафандры
For
не
Mars,
годятся. Перед
those suits
конструкторами
will
стояла
be
задача
different.
разработать гибкий, легкий, но
Dynas
очень прочный
was
панцирь,
supposed
чтобы
to
передвигаться и пешком, и на
Develop,
вездеходах.
design, light, flexible, easy to work with spacesuit. I will be able to work in this suit, I think.
Итак, все экзамены позади,
All
тренировки
tests are
закончены,
behind them.
экипаж сформирован,
They are totally
командир
trained,
назначен.
and we have a designated commander.
Экипаж готов.
The crew is ready.
Больных в строю нет, не понявших своего назначения нет. Настроение экипажа хорошее.
A good, healthy crew in good condition, reporting readiness.
Через 520 дней увидимся!
520 days later.
Задача нынешней миссии — долететь до
Task of this
Марса,
mission to
совершить
reach
на него
Mars,
посадку и
land,
вернуться домой живыми и
and
невредимыми.
come back unharmed.
Каждый день космического путешествия
Every day
наполнен
of the
опытами,
mission
исследованиями
is
и
filled with
экспериментами.
experiments
Появляется даже
and
ощущение,
research.
что всю программу не выполнить и за 10 лет.
It feels like it's enough to fill 10 years.
Диего, что ты сейчас делаешь?
Diego, what are you doing right now?
Я ввожу проводящий гель в электроскоп. Перед
This is
тем,
a
как снять
conductive
показатели
gel
до
that I'm
тренировки и
putting
после нее.
into the
Нам потом надо будет
system.
сделать
We'll need to check
энцефалограмму.
it before and after the experiment for
Еще 2 ночи
encephalogram.
с проводами спал.
So,
В голове их
I
приклеили, чтобы сон изучать.
slept like
Мне
this.
записывающее устройство 2 раза на
My
голову
dreams.
ночью упало. А с утра анкету
And the
заполнять.
recording
Там
device
как раз вопрос
fell
есть.
on my head a couple
Помните
of
ли вы
times when I
ночные
was
пробуждения?
asleep.
Как же,
It was
конечно,
funny.
помню. Если
And
бы
also
прибор
I'm
потяжелее
supposed to
был, то, видимо, не
write
помнил бы.
a
С каждым
report
днем Земля
every
становилась
morning.
все дальше.
I'm
И все
happy that
дольше до
the recording
марсонавтов
device
шел
was not too
сигнал из
heavy.
центра управления полетами. Теперь
We
любая весточка из дома, как глоток свежего
going
воздуха.
far and far, further and further away. I wrote messages to him. I was telling him that his mom is doing well, making sure that her blood pressure is okay. I shouldn't have
Орбита
been
Марса.
worrying him
Начинается
that
самая важная часть
mom was
космического
not doing so
путешествия.
well. So I was writing to
Экипаж
everything was
делится
well.
поровну.
So
Часть
the
остается на
crew
орбите,
is
часть готовится к высадке на Марс.
divided now operation-wise. Part of them will stay on the vehicle, and
Команде,
some of them
которая
will
ступит на
get
другую
out, getting ready
планету,
to
Александр Смолеевский,
get
Диего
on the Mars
Урбина
surface.
и
Smolyevsky,
Ван Юре.
Urbina, and Van
Десант переходит в
Yor
посадочную
are
капсулу.
EVA crew. They are ingressing a landing capsule. Bye,
Привезите нам
guys.
с Марса сувениры
Bring some
какие-нибудь.
souvenirs from
Камень
Mars,
какой-нибудь, например.
a stone or such.
Мало кто знает, что планеты нашей
Not
Солнечной
many people
системы
know that the
разговаривают.
planets of our solar
Вот сейчас
system
вы слышите,
communicate with
как
each
поет
other.
атмосфера
Right
нашей
now,
родной
you can
Земли.
hear the song of our atmosphere of the Earth.
А это голос
And
Марса.
this is the sound of Mars.
Возможно, планета, носящая имя бога войны, не слишком довольна тем, что какие-то дерзкие пришельцы пытаются потревожить ее
God.
тысячелетнее одиночество.
Planet is
О
probably
покорении
concerned that
Марса
somebody is
мечтал
supposed to
еще главный
disturb.
конструктор космической техники Советского Союза Сергей Королёв, когда
Sergei
строил
Korolev
свои
was
первые ракеты.
writing about it when he was designing his first rockets.
Земля — колыбель человечества, но нельзя вечно жить в
The
колыбели.
Earth
мы
is a
уже
cradle
сколько
of
лет?
humanity,
40,
and you
да?
should not stay
Больше
in your
колыбели.
cradle
На Земле.
forever.
Пора,
We've been there
уже
for a
лететь
while
дальше.
now.
И
It's
то,
time
что
to reach
Королёв
other
сделал
planets. And what
десятки лет
Korolev
назад, сейчас
did
еще нужно для
decades
того, чтобы
ago
отработать
is still
полет на
needed
Марс.
to design a mission to Mars.
Точка посадки на Марс — район кратера Гусева.
Landing site
Место выбрано не случайно.
is
По
a
данным ученых,
Gusev
именно в этом
crater
кратере есть лед,
on
и значит,
Mars
высока вероятность найти
because
следы
we
жизни.
have ice in that
Правда,
crater,
добраться до
and there is a
этих
high
ледяных
probability to
залежей
find
будет
water
нелегко.
there. However, it would not be easy to reach ice.
Так выглядит Марс на тренировках.
This is
Со
how
всеми
Mars
особенностями
looks
рельефа.
during simulations. The landscape
Два виртуальных
is
марсохода, большой
well
для перевозки
planned.
людей и малый
Two-
для сбора образцов. И реальный робот-марсоход.
transportation vehicles and one real transportation vehicle are at our disposal.
Minus 2 minutes to the start of the preparation of the EVA.
In 2 minutes, we'll have an EVA.
Впереди первый в истории человечества выход
ahead
на
of
поверхность
us-
Марса. За всей операцией наблюдает Центр управления полетами в подмосковном
Have the
Королеве.
first Martian EVA, and Korolov
Переход в
operators
шлюзовую
are
камеру.
watching.
Сложный процесс облачения
They're
в скафандры.
getting into the airlock, ingressing the
Всего
suits.
запланировано 3 выхода.
Altogether, there will be 3.
Еще 3 минуты. Да, за третьему. Если хочешь, можешь выключить освещение скафандра.
Сам выход физически сложен.
Physically,
32
it is
килограмма весит
demanding.
скафандр.
The
И вот 2 часа
weighs
работать,
32
имея
kilos.
такой вес,
Working in a suit for 2 hours is difficult.
У Юрия Гагарина пульс перед
Юрий
стартом был
Гагарин
152 удара в минуту. У марсианских
Heartbeat
десантников при выходе на
was
поверхность планеты сердце
152
билось со
per minute.
скоростью 160
Our
ударов.
Martian
Предел
EVA operators had a heartbeat of 160 per minute. This is the limit of excitement. We are ready to open the hatch, and here we are. Speak louder. By the 50th anniversary of the first human flight in space, our Martian spacewalk to that event. It is great that we also have a Chinese representative on the team. You have to make the first step. This is one of the first steps. The operation.
Мы большую часть времени смотрели
Most of the
под ноги,
time
чтобы не
we were
споткнуться
looking
о камни,
down
которые здесь
on
вы
the
забыли встречаются,
ground
и не
to make sure
запутаться
we do not
в шланге,
trip
через который
and not
подавался
get
кислород с капсулы.
tangled hoses that supply us with oxygen.
Во время одного из выходов на Марс
During
итальянец
one of the
Диего
EVAs,
Урбино
Diego
споткнулся и упал.
Urbino tripped and fell down.
Мы очень боялись этих падений.
We
в
were
принципе,
all very
потому что
afraid
боялись,
of
что сам он не
falls.
поднимется.
We were thinking that he would not be able to get up on his own.
Встать на ноги Диего помог Александр Смолиевский.
Alexander Smolyevsky assisted his crewmate to get up. He said it
Всего
was a soft
волонтеры
fall.
Красной планеты совершили 3 выхода на поверхность Марса.
Altogether, the
Правда,
volunteers
до
of
ископаемого льда они так и не добрались.
visitors visiting for
Однако
Mars
взяли немало
had
интересных
3
образцов скальных
EVAs.
пород,
They did not
наполнили
reach
контейнеры
ice, but
пробами
they had
атмосферы и
good
грунта.
samples of the ground and the atmosphere on Mars. Today we completed our planned activity on the surface of Mars, and we are leaving this red planet. See you next time.
На корабль ребята вернулись настоящими героями.
They came
Еще
back
бы.
as heroes.
Они первые земляне,
They
которые
are
ступили
the
на
first
поверхность чужой
Earthlings
планеты.
that stepped on another planet.
Да, похоже на то.
Like heroes should do.
Камень с марсианской поверхности. Ну что, поздравляю.
Congratulations. Welcome back.
Возвращение домой
Now
экипаж корабля
return to
решил
the Earth.
отметить концертом.
And
Исполнители
they
зрители
are
в одном лице.
celebrating the return.
Клавишные, ударные. Солирует, конечно, представитель солнечной и поющей Италии Диего
Of course,
Урбино.
the Italian is singing.
Дорога домой. Самая нелегкая часть пути.
Road back to the
За
Earth.
время, которое наши
This is the most
космические
difficult
путешественники
part
провели на
of the
Красной
mission.
планете, Земля по своей орбите убежала от Марса еще на 50 миллионов километров.
The
А
Earth
это значит,
is
что
even
марсонавтам
further.
придется срезать угол и максимально приближаться к Солнцу. К
They're
несчастью,
supposed to get
именно в
very
это время
close
на светиле
to
разразилась
the
мощная
sun.
магнитная буря.
Unfortunately,
Корабль
there
потерял
was
связь с Землей.
a magnetic
Восстановить ее
storm
удалось лишь через неделю,
at that time,
когда магнитная буря
and
утихла.
they
Все это
lost
время
communication
экипажу
with the
приходилось
Earth.
полагаться только на себя.
All of that time, the crew
Впереди
was
еще
supposed to
8
rely on
месяцев
themselves
уже
only.
надоевшего космоса и ставшие
Still
рутинными
ahead of them,
тренировки и научные
there will be
эксперименты.
8 months of travel and routine
Этот эксперимент
exercise and
называется
experiment
«Голубой свет».
activities. This
Сегодня мы
experiment is
сделаем
called blue
следующее.
light.
Мы наденем эти
Today,
очки,
we
которые
will
не
put
дают
these
голубому
glasses
свету
on
проникать
that
в
do
глаза.
not allow the
Мы
light
будем сами сообщать мозгу, что
come to
сейчас
our
день
eyes.
с помощью этого прибора. У
will
нас их тут
be
несколько.
ourselves
Эксперимент очень
signaling our
интересный. И
brain,
кто знает,
letting
может быть,
it
мы станем
know
немножко
that it is a
позитивнее,
day.
когда наш мозг
Maybe
будет думать,
we
что сейчас
will
день.
be more thinking more positive if we think it is a light time of the day and not a dark time of the day. As you see, all of us are participating in this experiment now.
Саша, занят?
Sasha, you
Нет.
busy?
Мы
No.
можем зайти к тебе с камерой?
May we
Да,
come to you with the camera? Yes, of course.
Итак, ой, а где твои очки?
Where are your glasses?
Я надену их через 10
I will
минут.
put them on 10
да,
minutes
он
from now.
отстает на 10
Oh yeah,
минут.
of course,
И это
he's
тоже
10
часть
minutes behind.
эксперимента.
This is also part of the experiment.
А я вот бороду ращу.
And
Не
I'm
отвалить,
growing a
просто
beard.
прикалываюсь. А сейчас отдыхаю от всех. И даже на
I am,
алкоголь не тянет. Даже желания не возникает по пиву проехаться.
Resting from
Ты его не
everybody. I
видишь,
don't
и
even
соблазна
want to have a
никакого.
drink anymore
И без
because you
него
don't
хорошо.
see it
Я за
anymore,
себя
and I know
начинаю
there is no
опасаться.
chance.
Вдруг
I'm a bit
совсем
worried about myself. What if I quit drinking altogether now?
Я написала Алексею, что ездила на
I
Финский залив.
wrote to
и
Alexei
прислала
that I
ему
was
фотографию. Мы
at
там
the
с ним были
Baltic
десятки
Sea
раз.
and
Ходили по
I
этому
sent him a
песку,
photo.
смотрели на
I've
воду.
been there
И тут
with
у него
him
такая
many times
реакция, ответное письмо
before,
я получила.
and now he
Море,
wrote back
море.
the sea, the sea. He was so excited to see a photo of the sea. 400th day of the mission.
В долгом полете космический рацион стал серьезной психологической проблемой. Особенно для Ван Юэ, которому так не хватало привычной китайской пищи.
Becoming
Диетологи
problem.
целого
Van
института
Ruya was
оказались бессильны.
very much missing Chinese food. Dietitians prescribed some substitutes for him.
В переводе с китайского это значит
In translation
«Милый
from
дедушка,
Chinese,
Константин
it
Макарович,
is
забери меня отсюда».
it reads, "Dear grandfather,
В
please
день
take me
рождения
back home."
марсонавты приготовили Ване сюрприз.
And
Они выпотрошили весь
this is
свой
a
продуктовый
surprise
запас в
for
поисках китайской еды, чтобы побаловать товарища по
Chinese
экспедиции и снять
crewmate.
его
They
психологический
found
стресс.
everything that resembles of China to him and just gave it to him.
О, лапша, моя любимая еда.
Oh, this is great.
Когда до Земли оставалось
Noodles,
лишь
Chinese
несколько миллионов
noodles.
километров, наши
When we
герои
had just a
занялись
few million
кулинарным творчеством.
of kilometers remaining for the mission, they started cooking. These are Martian
Мы вот
balls.
тут готовим марсианские шарики. Рецепт мы
This
взяли
is
на
what we are
Марсе.
cooking.
Вот используем его и
This is the
привезем
Martian
обратно на
recipe.
Землю.
We are going to bring it back to Earth.
Они сделаны из творога, понятия не имею,
This
из чего
is
он
cottage
сделан.
cheese
И из растопленных
and
шоколадок.
melted chocolate.
And this is just melted chocolate bars.
И еще тут есть какой-то русский секретный
There is
ингредиент.
some other secret Russian ingredient in there as well.
Кто сказал, что время течет с неизменной скоростью?
Who said
Когда
that,
торопишься, оно
that
словно
the speed of time
сжимается, и
is not
наоборот,
changing? When you
когда
are
ждешь
in a
чего-либо,
hurry,
растягивается.
it
И все же
compresses,
день
and
возвращения
when you're
приближался.
waiting for somebody,
На
the
518-е
time
сутки полета
seems longer.
корабль вышел на
On the
орбиту Земли.
15th
4
day
ноября
On the 4th of November 2011, they reached the Earth orbit.
Человечество сумело совершить самое долгое космическое путешествие.
To perform the longest
не покидая Земли.
manned flight, for now without leaving the Earth.
Сегодняшнего дня экипаж Марс-500 и земляне снова едины. Ура!
Mars 500 crew and the Earthlings are together. My father came back from Mars.
No, very good. Would you be willing to ask some questions? Do you have any questions on the...
You're the first audience to be here.
There's a question back there.
How do you like it? Эксклюзивный показ. So excuse the first viewing.
Thank you for sharing that with us, Dr. Yushikov. That was brilliant. I have a question regarding the incident. Wait till we get.
Go ahead.
I have a question regarding the incident where they lost power for about 18 hours. Was that a planned or unplanned event?
A very good question.
Конечно, нештатных ситуаций было значительно больше, чем показано в фильме.
Of course, we had a lot more off-nominal cases than what was shown. We demonstrated here only 2 off-nominal cases.
Нарушение системы электропитания и, соответственно, отсутствие
difficulties with power or problems with power supply system, which led to complete power down of many loads for about a day. And then another off-nominal scenario that you saw was loss of QAM for about a week, which demonstrated that the crew was very independent, autonomous, and didn't really need support, ground support. So this showed how independent and capable this crew was. Going back to loss of power, we did not prepare for that in advance. We didn't train the crew in advance for power loss. They didn't know that it will happen, but they did know that there will be various critical scenarios that may be difficult to handle, that will task them physically and psychologically. But they didn't know when these things would happen, how long they will last. So that was part of the experiment. We wanted to make sure that the contingencies that happen unexpectedly and would create very stressful situations. Thank you.
Good luck.
Thank you. I think that probably brings us to the end of our program. I would like to remind you of your evaluation forms. Should you get those in? And I think later this afternoon, probably by the end of the afternoon, we'll have the whole summit up on our website. It'll take us a little longer to get it up in Russian, but it'll be up in English later on today. Any other questions any of you have? Be glad to entertain them before turning it over to Bobby. Bobby, I'll let you close.
Well, thank you very much, George. It's really a pleasure to work with someone who's such an authority and has such an encyclopedic kind of knowledge about spaceflight and the history of spaceflight. He has been really, as I said, a delight to work with, and especially over these past 7 years in having the summits. All of that expresses one thing I think is very important. I believe I said in the beginning, I mentioned it the other day, that we really came from a beginning sort of process in a way to focus on collaboration and cooperation and coordination. And I think we've seen great progress in the past 7 years of having these summits and everybody getting together and sharing their thoughts and their wisdom, their experiences, and so forth. I personally want to express my great appreciation to all of you for coming and participating in this summit. I think it has real value in the picture of the whole world process of spaceflight and what humans can do when challenged and when determined. And thanks again for being here. We appreciate it.